Okay, so the next thing that we have here is another example, which is basically you want to find the standard deviation for this data. So you want to find the standard deviation for basically for this data, and the data that you have is something like this. You have your x of i's here, you have your f of i's here, you have your and they are basically 3, 8, 13, 18, 23, 3, 8, 13, 18, and 23. And the f of i's related to these observations are 7, 10, 15, 7, 10, 15, 10, and 6. Okay. Now you want to find the standard deviation. So the standard deviation, or sigma, basically, you know that your variance, we had something called the variance, which is basically called sigma squared, which is 1 over n times the sigma of So let's write down these formulas because we are going to need them. Let me take a look at these formulas. I'll come. Okay, so far we have had basically 3 formulas here. The first one was basically called variance, or which we call basically sigma squared, and that is equal to this thing over here, which is basically, we said that sigma squared is equal to 1 over n times sigma of x of I minus x bar whole squared as I goes from 1 to n, right? So that is called variance. The next thing that we had was that we took the square root of the same equation, and we said, and we called it basically that, then of course that becomes sigma is equal to the square root of basically 1 over n, or n lowercase or uppercase, sigma of basically x of I minus x bar whole squared as I goes from 1 to n, and that is basically sigma, which is called standard deviation, and we had this other formula which we derived for standard deviation as well, which you can write as sigma is equal to basically 1 over n times the square root of n times sigma f of I x of I squared as I goes from 1 to n, minus sigma f of I x of I as I is equal to, as I goes from 1 to n, and you have to raise this to the second power and to take the square root of this whole thing, and that is also called standard variation. Deviation. Now, let me make a screenshot of these three things and then we will go back to our problem. Okay, so I save this somewhere on desktop, call it, for example, statistics formula 3, for example, on desktop. And now we can work with this. Okay. Now if I go back here, I can use for example, let me come back to the example where I was. And then they have used, for example, this sigma alpha by x of y. Okay. So if I were to use this formula in order to solve this problem, and I want to find the standard deviation here, so what I need to do is basically the formula is let me write it down over here. So the formula is sigma, or standard deviation, is equal to 1 over n times the square root of n times sigma f of I x of I squared, as I goes from 1 to n, minus sigma f of I x of I as I goes from 1 to n, and you raise this to the second power, and then you take the square root of this whole thing, and that is the formula. So I need to calculate basically f of I x of I squared and f of I x of I, and then I can put everything in this formula and then calculate the whole thing. So now, for example, f of I, so what this formula actually does for you, now that I think about it, what this formula does for you is that you don't really have to calculate x bar anymore, meaning that x bar is already automatically calculated in this formula. So that's a good thing. You don't have to basically calculate x bar anymore. So meaning that it's enough to calculate f of I x of I squared, and then f of I x of I, and then you can put it in this formula and take care of the whole thing. So for example, f of I times x of I squared would be equal to f of I times x of I squared would be equal to, for example, 7 times 9 is equal to 63. 7 times 9 is equal to 63. 8 times is equal to 64, that's 640. 13 squared is equal to 169. So 169 times 15 is equal to what? Is equal to 5 times 1 is equal to 45, 4, 30, 34, 3, and 8, 0, 169. Then you have 5, 13, 1, and 14, 15, 1, and you have 2, 5, 3, 5. 2, 5, 3, 5. Again, 18 squared is equal to what? 18 squared is equal to 64, 6, 8, 14, 0, 18, and then you have 4, 12, and 324. So 18 squared is equal to 324. We are going to need this. So 324 times 10 is equal to 3240. Again, let's say that we have basically 23 squared times 6. 23 times 23, what is that? 9, 6, 0, 6, 4, and then you have 9, 9, 6, 0, then you have 46, so 9, 12, and 529. 529 times 6 is equal to 54, 12, and 17, 1, 31, so 3174, 3174. So that's one part. And then if you want to calculate for sigma f of I x of I squared, would be to calculate sigma f of I x of I squared as I goes from 1 to n. That's equal to basically all of these numbers added together. So you get 63, you get 640, you get 2535, 3240, 3174, 3174, you get 8 plus 4 is equal to 12. 1, 7 plus 4 is equal to 11, 11 plus 3 is equal to 14, 18, 18 plus 7 is equal to 25, 25, 2, 8, 8 plus 5 is equal to 13, 13 plus 6 is equal to 16, 1, and 3, 3 plus 6 is equal to 9, so 9652. 9652. So that's one thing. And then so I have this part, and then the only thing that I need to do is just multiply it by n, which is sigma f of I, which is equal to basically 17, 27, and here you have 21, 27 and 21 is equal to 48. That is 48. 17 plus 15 is equal to 17 plus 15 is equal to 2, so 32, and then you have 16 there, you have 48. So that is also taken care of. Now we need the only thing that we need is f of I times x of I. So f of I times x of I is equal to 21, 80, 13 times 15 is equal to, I don't know, 15, 1, 4, 0, 15, 195. 13 times 15 is equal to 195. 18 times 10 is equal to 180. 23 times 6 is equal to 18, 1, 12, 13, 138. 138. And then you can calculate sigma. You can calculate sigma f of I x of I as 2180 is 101. 101 plus 195 is equal to 296. 296. 180. And then you have 138. 138. So that's a 14, 1. 10 plus 11 is equal to 21. 21, 2, 4, and 6. 614. 614. And of course this kind of thing is of course all the time done with by a machine, of course, by calculator or some program that you write or something like that. But you have to first learn it here, and then you can give it to a machine to do it for you. So the next thing that we need to do, we need to put everything in this formula. And of course I need to calculate this whole thing. This is squared. So 614 squared is equal to, let's see, 16, 1, 5, 24, 0, 614, 0, 0, 24, 2, 6, 8, and 36, and so you have 6, 9, 8, and 9, and then you have 8 plus 8 is equal to 16. That's a 7, 3, 7, 6, 9, 9, 6. So sigma f of I x of I all squared is equal to 3, 7, 3, 7, 6, 9, 9, 6. Okay, and then so now this is equal to n as well, of course. Sigma f of I is equal to n as well. So your sigma is equal to 1 divided by 48 times the square root of n times, now sigma f of I x of I squared, sigma f of I x of I squared is basically this thing over here, and you want to multiply it by 48. So that's 48 times 9652 minus this basically this amount over here, 376996, 376996. And once you do this calculation, what you will get is, well, 9652 times 48, that's a 16.1, 40, 41, 4, 48, 52, 5, 72, 77, 0, 8, 22, 24, 26, 2, 36, 38. So you have 6, 9, 2, 13, 1, 16, and 4. So that's this number there. That is this number here. Subtract from that 376,996, 376,996, subtract 0, 0, and well, make this as 3, make this a 16, 15, 12, and 12. So that's a 3, that's a 6, that's an 8, and that's a 0. 86,300. That's 1 over 48 times the square root of 86,300. Now, in order to calculate that part, of course, all of these can be already given to a calculator. I don't know how normally students do this, for example, in 11th class or whatever they do. But in mathematics, you need to do calculation by hand, and until you shouldn't do it. But you should feel comfortable with numbers, and then, of course, after that, whether you do it or not is another story. But until you should do it, you should do it. So there is no rule. Individuals know for themselves whether they should give their numbers to a calculator or not. Otherwise, I have this calculator over here. I have scientific calculator here, but you need to do the work by hand whenever you should. Whenever you shouldn't, you shouldn't. And that I cannot tell you. There is no specific rules except for the ones that you're given in school, which is, I don't know, for you to judge. I'm not the judge of that. So, and then what you need to do is take the square root of this number, 86,300. You want to take the square root of this number. You make these groups of 2 digits. And then, for example, 2 times 2 is equal to 4, 3 times 3 is equal to 9. So 2 times 2 is equal to 4. Subtract, and you will get a 4 over here. Bring down 63. And then 2 plus 2 is equal to 4. Another digit here, another digit here. And for example, 5 times 5 is equal to 200. 48 times 8 is equal to 320, and there you have 64, that's 380. 49 times 9 is equal to 360 and 81, so you get 441. So 49 times 9 is equal to 441, and if you subtract, you will get 2 and 0. Get 2 zeros down here, and then you want to add 9 to 49. So 49 plus 9 is equal to what? 2 times 1 is equal to 18, 1, and that's 58. So you write the 58 over here, and you need another digit here, another digit here. So for example, and you want to get 2,200, so it must be something around 3 probably. So 583 times 3, that's going to be, or 4. 9, that's something around 1500. 240, and that is a 9, let's say. So that's 1749, right? Otherwise, if you go for 4584 times 4, you get 2000 there. You get 320 there, so it's already above 2200, so you need to go with this one. So a 3 over here and a 3 over here. So 3 times 583 is equal to 1749. And 1, 12, 11, 10, 9, and a 10. So you get a 1, a 5, and a 4. If I add 2 zeros here and bring them down, get 45,100. And if I add a 3 to 583, I get 586. 586. And another digit here, another digit here, and don't forget the decimal point. So you want to get to basically 45,000, and here you have 5,000. So 10 times 5,000 is 50,000. It's around 100. You have 800 here as well. So for example, 8 times 800 is something about 6,500. So if you go for 8 times, for example, 8 times 5,000 would be 40,000, and that's 8. I think it's too high a number. 8 doesn't work, but let's try it. So 8,5,8,6,8 times 8, you get 8 times 5,000. 8 times 1 is equal to 40, and then you have 3 zeros there. 8 times 8 is equal to 64 with 2 zeros. Then you have it 8 times 6 is equal to 480. Then 64. You get the 4 over there, you get a 14, a 1, and then you have 4, 4, 8, 9, a 6, and a 4. 46,000. I said that it wouldn't work. So if you go for 5,867 times 7, you would get 49, 4, 42, 46, 4, 56, 66, 35 plus 6 is equal to 41. So if you use a 7 here and a 7 over here, you would get a 41,069. 41,069. And okay, so you can make this a 0, 9, and 10. So that's a 1, that's a 3, 0, 4. And you can go for 1 decimal point as well, meaning that I can write this as, for example, it's 5867. 5867, add 7 to it. We'll get a 14, 7, 8, and 5. We'll get 5, 8, 7, 4, another digit, and the same digit over here. Bring these down. Bring these down. So you're looking for 403,000, and the number that you have is 58,000. So around 5 times, I suppose. So 58,740 times, I'm sorry, 45 times 5. See, 5 times 25, 2, 20, 22, 2, 35, 37, 3, 40, 43, 4, 25, 29. Oh no. I would say 8 probably. If you go for 8, you'll get 8 times 5 is equal to 40, and then you have 4 zeros there, and so that's 400,000. And no, not 5, probably. No, that was 8, right? So I think 7 would be the right number. 7. So if you have 5, 8, 7, 4, 7 times 7, you get 35, and basically 4 zeros there. And 7 times 8 is equal to 56 and 3 zeros. 56 and 3 zeros, and then you have some remainder there as well. So you would get a 0, 0, 0, 6, 0, 4, 4. No, again, you see it's already too much, and you get to that remainder as well. So go for a 6. Go for a 6. 6 will work. So 5, 8, 7, 4, 6 times 6, 36, 3, 24, 27, 2, 42, 44, 4, 48, 52, 5, 30, 35. So if you use a 6 here, you get 352, 352, 476, 476, and then you can of course do the subtraction, but you already know the answer. It's 293.8. You can take it. 200. So it's the same thing as basically 293.8 over 48. Okay, and you can take that as, if you can do all of this calculation by hand, then it's probably time not to do it if you don't want to do it. But as long as you cannot do your calculation without a calculator, you need to do it enough so that you can do it, and then if you don't want to do it, then you can just not do it anymore. But you need to be able to, if you're looking for a good condition, for a sound condition, as long as you cannot do your calculation by hand on a piece of paper without calculator, do it until you can, and then you can you can stop it if you want to. Okay, and then finally what we have here is 293 points. So you can divide both of these numbers by 2, for example. You get 293 is 145, and 3 would be 1.5, and this is 0.4, so you would get 0.9, and then you get a 6 over here, you get a 4 over here, 146.9, 146.9, and then you get 24 there. And then you need to see if you can still basically simplify this. This is divisible by 3, 3 times 8. This is 1 plus 4 is equal to 5, 5 plus 6 is equal to 11, 11 plus 9 is equal to 20. 20 is not divisible by 3. So this number is not divisible by 3. So now all that you can do, you can divide. So 146.9 divided by 24. So 5 times 24 is equal to something about 125. 6 times would be 120, and 24, 144, I suppose, right? 6 times 20 is equal to 120. 6 times 1 is 24, 144. So 6 times 24 is 144, and you get a 2 point, and you bring this 9, and 1 times 24 is 24, 5, 0, 0, 2 times 24 is equal to 48, 2, so that's something about 6.1, 6.1. So the final answer for your standard deviation is 6.1. Is 6.1. I think that's that must be the correct answer. 6.1. They have taken it as 6.12, but that's basically the same thing. So the standard deviation, or basically sigma, is equal to 6.12. And of course, you know that these don't have any units or anything. These are measures of central tendency, or measures of different behaviors of data in statistics. So they don't really have any units or anything. Now the next thing that we have here is some shortcut method to find variance and standard deviation. Let me see what that is. And then we have some exercises. Okay, so I think we will do that in the next video.